Hello everyone, welcome to another video about logarithm here on the Marvelous Math. My name is Michaelis, and on this video I want to talk about two logarithm properties, the product property and the quotient property. But first I want to just remember quickly an idea that we saw in the previous videos. So we saw that we can write a logarithm on the exponential form, and if we have it written on the exponential form, we can always rewrite it on the logarithm form. These expressions, they are interchangeable. So if I have the logarithm of L on the base b equal x, what I'm asking is to which power I have to raise b so that I find L. That will be very helpful to understand the demonstration of the properties. So let's see the first property, the product property. So if I have the logarithm of a times b on the base, the logarithm of a times c on the base b, and that's why we call it product property, because we have the product between a here or whatever two numbers you have, and the property says that it's equal to the logarithm of a on the base b plus the logarithm of cb. So the product of two numbers inside the logarithm becomes the sum of the logarithm of each number. But let's try to understand why that's the case. Let's call our logarithm of a in the base b alpha. So if I look back here, what I am asking is to watch to which number I should, or to which power I should elevate my base b to find a. So, and that what I'm saying here is that this number is alpha. So b raised to the power of alpha will be equal a. And let's do the same thing for the log of c on the base b. Let's call it gamma. So b raised to the power of gamma will be equal to c. But since we have the product between a and c here, let's do the same thing here. So a times c is equal to b raised to the power of gamma times b raised to the power of b raised to the power of alpha times b raised to the power of gamma, and that is b raised to the power of alpha plus gamma. So if we come back here to our logarithm form, what we are asking is to which power I have to raise b so that I found a times c, and the answer is that I have to raise b to alpha plus gamma to find a times c. So I will replace of a times c on the base b by alpha times gamma. Now, in the other side, what I have is a on the base b, and the log of a on the base b is alpha. plus on the base b, and the log of c on the base b is gamma. So it's actually very simple, and here we see why why we have this property. So always when I have the logarithm of a times c on a base b, I can open it and I can make it the logarithm of a on the base b plus logarithm of c on the base b. And now let's quickly apply this same idea to the quotient of a and c. So if I have the log of a divided by c on the base b, the property of the quotient says that I can rewrite it as the log of a on the base b plus minus the log on the base b. And if we do the same idea as we did there, if we have a divided by c, and we write using if we rewrite it using the base b, we will have a rewritten as b raised to the power of alpha, and c rewritten as b raised to the power of gamma. But I can as well say that it's b raised to the power of gamma, b raised to the power of minus gamma. Sorry, b raised to the power of alpha times b raised to the power of minus gamma. And I can rewrite it once again saying that b is equal to, saying that a divided by c is equal to b raised to the power of alpha minus gamma. So if I do the same thing as I did before, and I look here again, I have the log of a divided by c on the base b. So what I am asking is to which number I have to raise my base b so that I have a divided by c. And the answer for that is that I have to raise my base b to alpha minus gamma. So the logarithm of a divided by c will be alpha minus gamma. And this side, what we have the logarithm of a on the base b. The logarithm of a on the base b is here again, is alpha. And the logarithm of c on the base b is gamma. So again, it's very simple to see that when I have the logarithm of c of a divided by c on the base b, I can rewrite it as the difference between the logarithm of a on the base b and the logarithm of c on the base b. Well, that's the two properties I want to talk about. See you soon. Bye.